So welcome to this session, and in this session we'll be talking about Pandas. So Pandas, it's a module that helps to process CSV files. For example, we have a CSV file here, a revision, and then so we have lots of columns, and then have the year, the country, the region, artist, song, gender. And then if you observe carefully, you can see that there are some missing data. See, not available. Have lots of, you can see, not available, not available, not available. So Pandas can come in handy to process this data and then help us remove empty data. So remove empty cells or to update empty cells. So your Pandas can come in handy this way. So before we go to CSV file, let's try and establish how Pandas can help us, how we can generate a data frame from a list or from a dictionary. Yeah, so as you can see, we have a list, and then we can generate a data frame. So a data frame typically is like a table. I think I mentioned this at some point. It's a table. It looks like this. So your data frame would look like a 2D. So you have that, you have the columns, and that reflects the structure you find in your CSV file. And then you see, so that the data frame reflects this. And then we can generate that table. As you can see, we can generate a data frame from this dictionary. And then we'll pass our dictionary in there, and then we'll call our Pandas. You can see PD for short dot data frame. So use that function to what? Use the function to create a data frame, a data that reflects 2D. And you can see our data has got, as you can see, assigning numbers to the rows, and then you have A and B as columns, as you can find here. And then you can see that now. So that's how to create a data frame from a dictionary. And then, so let's move forward now. So imagine we have this data, and that's a dictionary as well. So you can see that's a key, that's the value over there. You have a key, you have a value, you have a key, you have a value. And then we can create a 2D structure from our dictionary. Then if we print it, look at how the output looks like. So you have our A, and A has got A1, A2, A3, A4. You have B, B1, B2, B3, B4. We can also say that we want to drop a particular row. Remember, axis 0. Your axis would look this way. Remember, your axis 0 flows this way from our NumPy, and then your axis 1 flows from left to right. So as axis 1 flows from left to right. So when we say we're dropping axis, remember our axis along the side is also labeled 0, 1, 2, 3. Yeah. So when we specify that we want to drop this axis 0, we want to drop data along this index. Remember, this is our index 0 here now. And then along axis 0. So that means it drops. So it drops like this. So that means it deletes whatever you have here. Remember, it deletes whatever you have here, following that direction. It deletes whatever you have here. And at the end, it will have cancelled this. So the cancellation will go this way, vertically, because your axis 0 flows from top to bottom. So it flows that way and cancels in that direction. That's why you find that this has been missing. You see? So you can also specify that you want to delete the last row. And then run it, and that would also reflect that you can see now. And then that action goes vertically that way, vertically, 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 in that way. And then not only that, you might also be interested, you might want to delete multiple rows. So for example, you want to delete 0, 1. So that means 0, 1, you're deleting that way. 0, 1, you're deleting it that way. 0, 1, you're deleting that way. 0, 1, deleting that way, that way, that way to the end. And at the end, you will have removed these 2 rows. That's what you have here. So if I run this one now, you will see that we have removed these 2 rows. So the same thing here. So you can also run this. Same thing applies here. And so we have this now. So let's imagine we have our data. Our data looks like this. We created a data frame from our dictionary. So this is our dictionary. So you can also break this down a little bit to say, okay, well, instead of having this, let's cut this one down. Put it this way, and then say our dictionary, and say D, dictionary. And I hope this makes sense. Yeah, so then we can put our D here, and this would still work. Yeah, it works. And then you can see this is our so this is our output. This is our demo data frame. This is it. This is how it looks like. You can see the name, John, Mary, Ali. I have age, 25, 30, 22. And then you have country, USA, UK, Nigeria. And then we can use iLog. So this is like indexing. You want to print, okay. If you look at what we did here now, let's see. Okay, we didn't print this one. But what we did here, was to say, okay, well, can we look at, so let's look at our row from 0 to 2. So we have our row here. So from 0 to 2, take all the columns. So that is what invariably what is happening is it's printing all the items. So we are saying I'm on line 10. I'm on line 10, and we say that take, so your iLog would look at, because we specify here that from 0 to 2, so it will take from 0 to 2 all the rows. So this row, that row, and the last row. And then what happens is it picks all the items there. And then that would give you this one. I hope I'm right. I hope I'm right. I hope I'm right. Let's see that. Let's see this one. Okay, yeah, I'm right. Let's take this out. Yeah, I'm right. Yeah, so what it did was, remember, this is also exclusive to, I think I forgot that. So if you want to take it to the end, this would have, exactly. So this is exclusive. So it does 0 to 1. So what we are saying here is that take all the rows from 0 up until 1 and spit out the columns in there. And that is why you would find that it's not printed the last one. So it does 0 and 1. So it takes 0, it takes 1. Remember, I do not take 2, which is here now, because it's exclusive now. It stops a number before that. Then it spits this out. And then, so that is your iLog. Your iLog, you usually use it when, I think I wrote something here. Okay, then you use iLog when you have, you use your iLog when you have numbers. Just like you have your index here. index 0, index 1, and then you can use your iLog to look through those rows. But there are times that, let's look at this now. There are times that you already have labels for your rows. And see, instead of having 0, 1, 2, you have labels A, B, C. In that case, your log comes in handy. So your iLog, which I stands for indexing, would work when you have numbers by default. But there are times that you might want to specify your row names. You can see A, B, C. In that case, your log would come in handy. You can use your log now to say, well, I want to log onto a row that has label B and print all the content there. And this would log onto this row and then spits out this. And that's what you have here. If I run this one and say it spits out Mary 30 UK, and that's what you have here. Okay, then, so let's go to, so here you can also upload a CSV file. You can see I've done that. You can click on this one and then upload your CSV file. And once you are done with that, you can do some analysis. Remember, I looked at that CSV file earlier. So that can see the CSV file, and then we can begin to do some analysis on some columns. So let's imagine that we are interested in the points. I want to find out the total number of points for this. So what we do is to read, use our pandas to read that CSV file. And we are specifying that SN is our index, so it has index. So we just specify that this is just the index, yeah, SN. And then so once we read that, we have our data. And from our data, we can log onto a particular column, which is this column here. Which is this column here. And then it collects all the data here. And what happens? It will do the sum for us, and then we can print the sum. You can see now that the total number of points we have there is this, and then we can print that out. And then we can also do some analysis to say, okay, well, on that data, log onto column points and fetch us the minimum value, and then assign it to this. That prints the minimum value. So the minimum value on that column is 0, and the maximum value on points column is what is 387. So we can actually go through that Excel CSV file to look at 387, and we find 387. That's a long walk. Yeah, 387 at some point, but at least we know that 0 is the minimum, which is true. Then just have 387 somewhere. Yeah, so you can do that exercise on your own. I hope we are together. I hope, okay, so yeah, so we can also move for that to say, okay, well, read that CSV file and pick these columns for me, points and gender. So pick, so this is our Excel, read our Excel, and this represent our data frame. Remember, this is our data frame, and you can see now, you can see it's of type data frame. That means our data is in a 2D format. From this 2D format, pick out these two columns. So we're interested in this point column and artist gender column. So we're now saying the answer, can you group the points based on artist gender? So in Rebel, we are saying accumulate the points that an artist that has both, get the points for an artist boot, get the total point for artist female, and also get the point for artist male. That's what we're saying here. So here now, these are data frame. From this data frame, pick the points for all artist gender, and then group the points based on what artist gender. So invariably, we are saying, go to that CSV file, read there. Yeah, so go to this CSV file, and then go to point and artist gender. So points and artist gender, and then so look at male, and then sum the total number of points for male. So to male 23, then look for male again, male. So it becomes 23 plus 120, and it does that for male. Same thing for female. Female has 53. So female here becomes 53 plus 107, and then 53 plus 107 plus 3. It does that for all the numbers. I mean, the genders, yeah. Okay, then, so another thing we would also want to do is to try to find out how many columns have got empty cells. So this is what it is not available does. So we read our data. So we have our data frame, and this data frame we're not saying, okay, well, it's not available. Can you give us the total number of empty cells per column? So here you can look at the breakdown now. So it's telling us that year has got no empty cell, country has no empty cell, but you can see artist gender has got 422 empty cells. And then if you go there, let's go to the column. And then artist gender. So this one has got, let's look at it. You can see now, we have a lot of empty cells. A lot of empty cells. How do we process this? That's a problem. A lot of empty cells. So you can see group solo 2, a column has got all of this. This one has got 367 empty cells. We have energy column 166. That's a whole lot. So how do we do this now? There are two methods to removing empty cells. I hope we are still on the same page. So the first thing we need to do is that, okay, well, maybe the first thing that we can do is, you can see now, maybe we should remove any row with an empty cell. That's going to be the first method. So anytime we see an empty cell, so look at, yes, now, so we have an empty cell here. We can remove, delete this column, delete this column, sorry, delete this row, anywhere we find empty cell. So that's the first strategy, which means drop not available. You see now? So what we did here was to say, okay, well, read the CSV file and drop not available. So drop any row that has any empty cell, any row. So once you do that now, run it, you can see now. Let's see it again. And then, so once we drop any row, you can see drop not available, drop any row that has no data, not available. Once you are done with that, we can now say, well, data dot is not available. That means now, once you have dropped empty rows, now count the number of columns and count the number of empty cells per column. Then you can see now we do not have any empty cell. So that means we have cleaned our data. You can see, as opposed to this that we ran. So the first strategy to remove empty cells is to do what? Is to drop. So now, there's a trick now. This in place true, it means something. So remember, once we read our data, it is assigned to data. Our data is a data frame. Data frame is like a table. So we're now saying this table, whatever updates you are doing, do it inside that table. That is what this true means. That is, do it inside. The update should be inside. Are we together? Are we together? So that is what it means. And then we have done that. Yeah, so there are times that you want to also do there are times that you would also want to say, okay, well, false. So in place here means false, which means you are not updating on the current data frame. So a copy has been made and the changes are made on that copy and the copy has been sent to K. So if we now do K dot it's not available dot sum now. So if I do this now, print is that what we did earlier? Let me print this one. I hope this is clear. So you can see now. So I've printed K. I've printed answer. You can see we've removed all the zeros, all the empty cells. But if I do this now, if I now do data, let's see that now. I think I made a mistake. Okay, let's do this one. It should be this one. K dot sum. And this should give us, take this one out. You can see now, you can see the update was not made on data. The update was made on K because of this false. In place false, which means the update you are making, it is not on data. The update, you have a copy of data, and then that update will be given to K. I hope this makes sense. Okay, then, so we've set this one. The next challenge, I mean, the next approach to say, well, instead of you deleting every row with empty cell, what you can do is to also look at column by column analysis to say, okay, well, look at this column. We have empty, from an analysis here now, we have empty cell here. Artist gender, that is 44. I mean, 422 empty cells. And then we now say, okay, well, this data, look at this column and find the one that appears the most. The data, I mean, the data that appears the most. It could be male, female. So we're here. We are here. And then we look at the one that appears the most. Let's say it's female. We'll now use that to fill up those empty spaces. That's another approach. So have a mode and then use that mode now to say, well, this column dot fill not available with the what? With the most, which is the female. In this case, it could be female. So if I print this one, I print the mode. Now let's see the mode. Let's see the mode. And then you can see female. You can see female. So it appears as a time series. So that's where we are picking the first index, female. So female appears the most, and then it takes that one and then fills it with it now. And then once we are done with that, you can see artist gender has been filled now. We don't have any empty cell. I hope this makes sense. So, and then the next one you want to do is to also use the mean to fill up empty cells. You can also use the mean. So you look at, for example, a column called happiness. Let's look at that. So we have that. Happiness. Yeah. So we look at happiness, and then we try to do the average and then fill those empty spaces. So that's what we did. So yeah, average. So the mean, get the mean, and then on that column, fill the not available, that empty spaces with what? With this value you have here now. So if you print this value, it tells you the mean. And then you have the mean. So you can see this is the mean, and then it fills that up. And then if you look at happiness, happiness has got what? So you have to be looking at every column to do the analysis. Okay, so finally we have this one. This one says calculating total points for each country in the data set. We read and then we group the country based on points. Let's run it now. Do you have something here? So we can see. So you group the country based on points. See that now, group by country based on points. So you accumulate all the points for each country and then you sum it and then you have this output. So as an assignment, you can also do this one and this one. I hope this video has been helpful. See you in the next class.